Let's talk about how to perform a dilation in the coordinate plane if you're using a point other than 0, 0 as your center of dilation. When using the origin as the center of dilation, remember from last lesson that you just multiply each of your coordinates by the scale factor. We're going to have to use a little bit of a different process if we're using a point other than 0, 0 as our center of dilation. Instead, we're going to have to count the horizontal distance and the vertical distance from the center of dilation to each vertex. Then we'll multiply that distance by the scale factor, and that's how far we'll go from our center of dilation to each of the image coordinates. Let me show you what I mean. Here we have triangle DEF, and the center of dilation is point C, 2, 2, instead of the origin, 0, 0. Our scale factor is 2. To find the coordinates of the image, we need to do double whatever we did to get from the center of dilation to the pre-image points. It's really important to note that every single time you do this, you're counting from C, from the center of dilation, to each vertex. Don't go the opposite direction. You go from C to the vertex. So from C to D, we go up 1. So I'm going to multiply that distance by 2 to get to D prime. So from C to D prime, I would go up 2. 1, 2. So this is where D prime is. Next we'll go from C to E. To get from C to E, we go up 1, 2, 3, 4, and to the right 1. Up 4, right 1. So we're going to double that to get to E prime, which would be going up 8 and right 2. So from C, I'll go up 1, 2, 3, 4, 5, 6, 7, 8, and to the right 2. And to get from C to F, we go down 1 and right 3. So to get from C to F prime, we'll do double that, down 2 and right 6. So from C, I'm going to go down 2 and right 6, and that's F prime. Connect those 3 points to form a triangle, and that is the dilation of triangle DEF using a scale factor of 2 and the point 2, 2 as the center of dilation. Let's try another one. Here we have trapezoid trap, and we're going to dilate it using a scale factor of 3, and we're going to use the point C, -8, -9 as our center of dilation. So going from C to each vertex, let's figure out the distance. From C to T, I just went up 3. So I need to multiply that by 3, because that's my scale factor, to get to T prime. So to get from C to T prime, I would go up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's T prime. It's 3 times as far away from C as T was. Now let's do the same thing for R. For R, I go up 6 and right 2 from C. So I need to triple that to get to R prime. So I'm going to go up 18 and to the right 6. So going up 18 and to the right 6 puts me here for R prime. Now from C to A, I go up 6 and right 4. So triple that to get to A prime. I'm going to go up 18 and right 12, which puts me right here. So up 18 and right 12 from C. And last but not least, we have P. To get from C to P, you go up 3 and right 6. Multiply that by 3 to get to P prime. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and to the right 18, and that's P prime. So this trapezoid is the dilation of the original trapezoid using a scale factor of 3 and the center of dilation of -8, -9. Our first 2 dilations were enlargements, but we can also do the same process if it's a reduction as well. I'm going to be dilating triangle ABC using a scale factor of 1/2, and our center of dilation is the point C, to -7. You'll notice that this time our center of dilation happens to be one of the points on the figure. Let's see how that plays out. So from C to each vertex, we'll go C to A first. From C to A, I go up 10 and left 8. So I need to do half of that to get to A prime. Instead of going up 10, I'll only go up 5. And instead of going to the left 8, I'll only go to the left 4. So 1, 2, 3, 4, 5, and to the left 4. So there's A prime. Let's do the same thing for B. To get to B, you go up 15 and right 7. So I need to do half of that to get to B prime. And yes, that means you're going to have decimals, and that's totally fine. To get from C to B prime, we just go up 7.5 and to the right 3.5. So 1, 2, 3, 4, 5, 6, 7 and half, and 1, 2, 3 and a half. So there's B prime. And then C, well, to get from C to C, you don't go anywhere. You just go up and down 0 and left and right 0, so multiply 0 by half and you still get 0. In other words, C and C prime are the same thing. Anytime your center of dilation is one of the points on the figure, that point won't move. So this little triangle is the dilation of triangle ABC using a scale factor of 1/2 and a center of dilation of 2, -7. And that's all you need to know about dilations, and that's actually all you need to know about similarity. This lesson wraps up our unit on similarity. Next unit, we're going to be moving on to kind of a special case of similarity, which is called trigonometry.